Okay, so this is our first venture then into watching a video and taking notes over it. So on a brand new page in your notes, what I want you to do is in heavy lettering, I want you to write VodCast 9-1 or in capitalized letters. Okay, and then write oxidation numbers. So when I go to your notes and I look through them, I can easily see, okay, this is VodCast 9-1, and you have the notes over oxidation numbers. Okay, so if you do that right now. Okay, so the first thing we're going to talk about are what are called oxidation numbers. And this whole chapter is actually all about naming compounds. But in order to name compounds, we actually need to know and write formulas. We need to know the charges of atoms. Okay, oxidation numbers are the charge of an atom in a compound. That's all an oxidation number is. So basically in the last chapter we dealt with oxidation numbers. I just never used that specific term. Okay, so if I go and I write the compound NaCl, okay, hopefully you remember that the charge of Na was +1, the charge of Cl was -1. Well, those are technically called oxidation numbers. Where this is going to get tricky is when we talk about the apparent charge of an atom, okay? Because not all atoms' charge are really straightforward. So an oxidation number is also referred to as the apparent charge of an atom. Okay? Now, things that you absolutely must know, okay? And if you don't know these, then I haven't been doing my job, and you haven't been doing your job as a student. Okay, we absolutely have to know the charges of the main group elements, and we better by now we better know what the main group elements are. Okay, and the charges of the main group elements are: group 1 is +1, group 2 is +2, 13 is +3. Okay, if you remember in group 14, it had the element carbon, and carbon likes to share and form covalent bonds. So we could say +3 or +4 or -4, but we don't really know. Okay, and then 15 is -3, -2, -1. Okay, and remember, or something to watch out for, there are always surprises along the way. But remember, these are losing electrons to become stable. And these are gaining electrons to become stable. Okay, so some things to remember. But yes, okay, where I have here, be prepared for surprises, that's where this whole idea of apparent charge comes into play. This apparent charge, okay, that's where some surprises that we're not used to are going to come into play. Okay, some things to know for certain. Groups 1 and groups 2, their charge never change. So a group 1 element, you know its charge is always +1. That is very helpful when we're trying to determine charges of some things that we don't know. If I have a group 1 element in the compound, I absolutely know it's +1. And if I have a group 2 element in a compound, I absolutely know it's +2. Okay? Another good thing to know is fluorine never changes. Fluorine, it always has a -1 charge. Okay? And I'm going to come back to this one and talk about this one in a couple slides. But 99.9% of the time, one of the things that we always know is oxygen is a -2 charge. Okay? Now, where you come into problems, okay, are with nitrogen, phosphorus, sulfur, and chlorine. And if you look on your colored periodic table and you see inside the little box that those have multiple charges in them, those charges will change depending on the compound that they are with. Okay, so that is one thing to be aware of, is that those particular ones are going to change. Okay, and so what I'm going to do here is, first of all, talk about when they won't change. Okay, so if I have nitrogen, sulfur, chlorine, and phosphorus, and they are in what are called binary compounds, okay, they will have the primary group charge. And what I mean by that is, okay, if nitrogen is in group 15, that primary charge is -3. Okay? Phosphorus is also in group 15. Its primary charge is -3. And sulfur is in group 16, and its primary charge is -2. Okay, these are the ones that are going to be the most frustrating. And again, because if you look at your colored periodic table and you look in the element box, one of the things that you will see is those have multiple charges. Okay? So, what we're going to look at here is just some binary compounds, okay? Now, first of all, you need to define the word binary. Binary is only two different atoms that make up the compound. In fact, that's one of the first naming systems we're going to do is the binary naming system, okay? But, again, if I have this compound, Na2S, and I want to know what the charges of the atoms are, okay? One of the things is one thing I talked about, okay? Na, we've always said, is a +1 charge. Why? Because it's always in group 2, okay? And in this particular case, because you have two +1 charges, okay, sulfur has to be a -2. Okay? And I actually should go ahead here a little bit. Okay, when we're talking about determining the charge of an atom in a compound, okay, one of the things that we need to actually do is remember that the total charge of the compound must be 0. Okay, and I kind of should have done that first, I guess. Okay, but that's one thing to remember, is that the total charge must be 0. And we've actually talked about that in the past, so that's something that's more of a review. So that's why when I go back to this particular compound, okay, this 2 right here means I have 2 NAs. Each one is a +1, so a +1 plus a 1 plus 1 plus -2, that's my net charge of 0. Okay, and these charges right here, okay, those are the oxidation numbers. Okay, let's go down to MgCl2. Okay, I want to know what the charge of Mg is and what the charge of the Cl is in this compound. Okay, well, number one, Mg is a group 2 element. Group 2 elements are always what charge? +2. So, by default then, if I have 2 chlorines, each chlorine must be a -1 charge. Okay? So, that -1 then is the oxidation number of chlorine, and +2 is the oxidation number of magnesium. Okay? How about you do these last 2 and see if you can't come up with the oxidation numbers of those 2. Okay, Ca is a group 2 element, and nitrogen is a group 15 element. Okay, so Ca being a group 2, its charge must be +2. Nitrogen being a group 15, its charge is -3. Okay, and the last one, Fe and phosphorus. Okay, Fe in this case is a +2, phosphorus is a -3. Okay, and remember, these numbers are all called oxidation numbers. And all that means is charge. These numbers are the charge of the atoms. Okay, now, we're not going to do anything with this right now, but just to show you, the problem comes in with these when elements are in compounds that have 3 or more elements in it. Okay, that's where some of our problems are going to lie. Okay, and we're going to have to figure out what the oxidation number is of all of these. As an example, and I don't know why I didn't put one here, but if I have HNO3, okay, there's that nitrogen, and in this particular case, that nitrogen is not going to be a +3. So there are some other rules that we need to learn. Okay, I've already said that I would come back to this, but the first thing we're going to talk about is oxygen. Okay, and again, oxygen always has an oxidation number of -2. In almost every single compound you come across, it will be a -2. If you're not sure, then -2 is a good safe bet. Now, knowing that oxygen is a -2, that will help you find the charge of oxygen or charge of other elements. Okay? For example, let's say I have CrO. Okay? Now, I want to know what the oxidation number is of the Cr and the oxygen. And usually when you're finding oxidation numbers, you split everything back apart. Well, if I know the oxidation number of oxygen is -2, well, I know that the overall charge has to be 0, so this must be +2. Okay? And that's how you can use it, and it can be useful. The one thing I want to talk about right away is the exception. Okay? And the exception for oxygen is when oxygen is with a group 1 element, then it's -1. But that's the only time it's -1 is when it's with a group 1 element. And these are called peroxides. You are actually very familiar with one of the most common peroxides. Okay, this H2O2, its technical name is hydrogen peroxide. And I'd be willing to bet almost every one of you has this in your house. Okay, it's a common household chemical. We use it to treat cuts and bruises and things like that, more cuts than anything else. Okay, but as you can probably see, in this case, oxygen is a -1. But the hydrogen, and that's really because we already know that hydrogen has to be a +1. Okay? And then you're going to say, well, you told us a long time ago that I can't double things up. And I've also told you a long time ago there are exceptions to everything. Okay? This is an exception when you have peroxides. Okay? Here's another good example. Okay? The Na here and the oxygen. Okay? We've already said group 1 elements are always +1 charge. So that sodium has to be a +1 charge. Okay, well, and if that's the case, then oxygen has to be a -1. That's the only way I can add these two together and get 0, because the total charge of your compound has to be 0. Okay, so peroxides are the exception for oxygen. Okay, so what we're going to do here is we're just going to do a little practicing, okay, with some basic elements, and we're going to find out what are the oxidation numbers of each element in the following compounds. Okay, so we're going to split these compounds up, Mg and O. And all you're doing is breaking these apart. In the last chapter, we were putting these compounds together. Now we're just breaking them apart. Okay, and this is where it's good. Okay, Mg I know is not a group 1 element, so I know oxygen's -2, so Mg must be +2. Because those two added together have to equal 0. Okay? If I go with Sr and Cl. And notice I'm not writing Cl2. Okay? Because all I'm doing is I am breaking these apart into the individual atoms that they are. Okay? Now, a couple ways to go here. We can look at strontium and we can say, okay, strontium is a group 2 element. So that's plus 2. Well, and then I have 2 chlorines, so what does each chlorine have to be? Each chlorine needs to be a minus 1. Okay, because if I have 2 chlorines at minus 1, now when I add all these together, I get 0. Okay, so the oxidation number of chlorine is minus 1, and the oxidation number of strontium is plus 2. Okay, how about K and S? Go ahead and write down what you think their charges should be. Potassium, group 1 element, plus 1. Sulfur, minus 2. Okay, because I have 2 of those group 1 elements. Okay, by the way, you should have your periodic table out if you don't. Okay, I want you, okay, I'm going to do one more. Let's do Al and F together. Okay, you have a couple of things. Number one, earlier I said fluorine is always minus 1, so you know what that is. And then you go to aluminum and you find aluminum's in group 13. Group 13s are plus 3. Okay, now what I want you to do is I want you to take those 4 compounds and I want you to write the charges of each. Okay, you should have unpaused the video right now. So if I look at this, Cu should be plus 1, Co minus 1. Cu and Br in this case, Br minus 1. Copper then has to be plus 2. This is going to be an issue that we'll talk about later, but the same element can have multiple charges. Okay, Ni and I. Iodine's a group 17 element, so it's minus 1. I have 3 of those, so that's a plus 3. Okay, titanium and oxygen. Okay, if I'm not sure, okay, I know this is not a group 1 element, so by default that must mean oxygen's minus 2. Well, I have 2 minus 2 oxygens, so that total is minus 4. So in order for me to get to 0, that must be a plus 4. Okay? So those are oxidation numbers of some binary compounds. Okay? The problem you're going to have, or one of the problems, is when you have 2 nonmetals. Okay? And in particular when you have covalent bonding. Okay, I really didn't point this out, but these were all ionically bonded substances. So one of the problems is how do you determine charge when you have 2 nonmetals? And then this is the case where one of the things I said earlier is actually a partial lie because, well, it's not a partial lie, it's just that it wasn't the total truth, I guess. Now, you're going to have sulfur that's going to be a problem because sulfur is a group 16 element. And we're going to want to say that it's minus 2, but oxygen is always negative. Okay, and in this case, oxygen's negative 2. So sulfur, in order for this to work, has to be a plus 4 because I have 2 oxygens. Each oxygen is a minus 2. Okay, so in order to get to my 0, okay, that sulfur has to be a plus 4. And this is where the term apparent charge comes into play. Okay? And nobody likes this because it doesn't follow all the set rules that we've had to this point, but this is the apparent charge. Okay? So, if I go to PCl3 then, okay, phosphorus is not in its normal place. Okay? So, phosphorus is not going to be what it thinks it says in group 15, which should be a minus 3. Okay, one of the things to note is all these leading elements have to be positive because of one of the things that we said earlier, and that was that positive elements go first. Okay, now this is binary, so chlorine is going to be its minus 1 because it's the second element there. So this phosphorus has to be a plus 3 because there are 3 chlorines. Okay? Carbon and oxygen. Oxygen minus 2. So what do you suppose the carbon is? And you should realize we have 2 minus 2's. That's what this 2 means, which is minus 4. So that has to be plus 4. Okay? Go ahead and put the oxidation numbers that you believe nitrogen and oxygen would have in this NO3 compound. Hopefully to the point where oxygen is always minus 2. And now this 3 right here means I have 3 minus 2's for a total of minus 6. So what does nitrogen have to be? It has to be a plus 6. Okay, and now that makes this one real interesting because now I only have 1 oxygen. Okay, and this does work. It's something called the law of multiple proportions, and this is actually later on in our chapter. Okay, so I'm not going to worry about it right now. But again, oxygen's minus 2, so nitrogen has to be plus 2. And this is why on your periodic table you have lots of multiple charges for nitrogen, phosphorus, sulfur, even chlorine. Okay, has lots of multiple charges. Okay, I'm going to go on to another issue. Hydrogen. Okay, we've kind of already seen this. Hydrogen is always always a plus 1 because it is a group 1 element. So it should follow what all the other metals do. But the problem is hydrogen is its own little unique group in the fact that it's a non-metal in a hydrogen group. So it's kind of an outcast. So hydrogen is always plus 1 except the chemist's favorite friend, there's always an exception, when it is with a metal. Then it is minus 1. Okay? Now, we'll start with this H2O. Okay? And actually I have a whole bunch of examples here. Okay? H2O, okay, I have hydrogen and oxygen, but one of the things that you need to realize is neither one is a metal. So oxygen is minus 2, hydrogen plus 1. They're both 2 nonmetals. And then NH3, this is a whole new example where these 2 actually get switched around and nobody's going to like this. Okay? But they are 2 nonmetals, and this is the one case in the chemical compound world where the negative gets written first, and that's because of history. Okay? Throughout history, this compound has always been written as NH3, and it's never been changed. Okay? So it's just tradition, basically. Okay? But now, I get into Li and H. Li is a group 1 metal. It has to be plus 1. So hydrogen has to be minus 1. Magnesium is a metal. Okay, and it's plus 2. So this hydrogen has to be minus 1. Cobalt and hydrogen. Cobalt is a metal. So this is minus 1. This is plus 3. So that's the hydrogen exception. Okay? Now, we have one other issue with oxidation numbers. And that issue is back to these polyatomic ions that we learned about in the last chapter. Remember, these were a group of atoms with a charge. That was the definition of polyatomic ions. So in a polyatomic ion, the total charge of the atoms now must equal the charge of the polyatomic ion. So instead of equaling 0, okay, my charge has to equal that -1. Okay? Now, in order to do that, whatever the charge of nitrogen is, plus whatever the charge of oxygen is, it must equal this charge on the polyatomic ion. So here's the deal. Oxygen is still -2. Okay? But I have 3 oxygens. So their total charge is -6. And I really should write that. The total charge of oxygen is -6. Okay? So now, I have 1 nitrogen. So some number plus -6 has to equal -1. That number would be 5. 5 plus a -6 is -1. Okay? Now we have a whole new charge of nitrogen that we haven't seen before. But that's the way it is. Okay? Let's look at another one. Okay? So in this particular case, whatever charge chlorine is plus whatever charge oxygen is has to equal -1 again, because that's the charge of the polyatomic ion. Okay? And again, oxygen isn't going to change. Oxygen is always -2. So I have 3 -2 charges. Okay? So that gives me a total of -6 for oxygen. I should put -6 there. -6. Okay? So oxygen's total here is -6. Well, what does this chlorine have to be? And again, this goes back to simple math. It has to be at +5. Okay? PO4 3-. So my total charge of the phosphorus plus the total charge of the oxygen has to equal -3. And again, it doesn't matter if I say 3- or -3, either one. But one of the things you'll notice is all these polyatomic ions seem to have oxygen in them, because that is the key element in a polyatomic ion. So that really helps. Now I just have 4 -2 charges. So my total charge of oxygen is -8. Okay, and this wasn't on purpose, okay, but what is the charge of that phosphorus? And hopefully you're saying +5. Okay, and I have one more example with this. Okay, SO4 2-. Total charge of sulfur plus total charge of the oxygen has to equal, I'll write it that way, 2-. Again, there's that oxygen. I have 4 of them. I have 4 -2s. And if it helps you to do that, then go ahead and write those out. Those all added up gives me -8. So I have a -8 here. Okay? So the sulfur then, in order to give me a 2- charge, should be +6. Hopefully that's what you're writing. Okay? There are many, many polyatomic ions. Okay? And this is something that you'll work with, and hopefully you'll eventually get good at it. But it takes some time. Okay? Working with these particular polyatomic ions takes a little time. 2 last issues. Okay? any uncombined element will have an oxidation number of 0, and I should have put a comma in here, along with diatomics. Okay? So basically what that means is if you just see a lone aluminum and it's not combined with anything, its charge is 0. Okay? If I have a magnesium atom, okay, and it's not combined with anything, its charge is 0. Now this also works with diatomics. If I have O2, its charge is 0. If I have N2, its charge is 0. If I have Cl2, its charge is 0. All the diatomics. And you remember that there are how many diatomics? 7 of them, correct? Okay. And then last but not least, if you have a lone ion, its oxidation number is equal to its charge. So you will literally see on the paper S2 minus. Okay, and S2 minus, that's its oxidation number. You would see written P3 minus, that's its oxidation number. Ti, that's its oxidation number. So if you ever see charges as written, that's what their oxidation numbers are. Okay, so this is the fun one. How do you deal with this? Okay, I want to know the charge of each and every element in this compound. Okay, and I want to know the oxidation number of it. Well, oxygen we know is always -2. Potassium we always know is +1. So when you have these compounds, what you should do the outside elements first. Okay, that will help. Always do the outside. And one of the things that you're going to see, okay, there's always oxygen in them. Okay, so that's going to help you because we always know what oxygen is. Okay, but remember, we have to equal 0. Okay, so in this compound, I have 1 potassium that's a +1, and I have 4 oxygens, each at -2, so that's a -8. So +1 plus some number plus a -8 has to equal 0. So what does this chlorine have to be? +7. Okay, let's try this one. I have hydrogen, phosphorus, and oxygen again. Okay, we know oxygen is -2. It's not with a group 1 element. And we know hydrogen is a +1 because it is a group 1 element. But now I have 3 hydrogens. Okay, so I have 3 +1s for a total of +3. Okay, and I have 4 oxygens, each at -2. So that's a -8. So I have a +3 plus some number plus a -8 has to equal 0. So what does that phosphorus have to be? And hopefully you are saying +5. Okay? One last one. This one looks challenging, but it's really not too bad. Okay, I have Mg, B, and O. Well, we know oxygen's -2. We know Mg is a group 2 element, it's +2. All right. So now I just got to figure out this boron, okay? But I have 1 Mg. But I have 7 oxygens. That's what that big old 7 means right there. So that is -14. And if you can do that in your head, which, you know what, you see -7 here, you should be able to go -14. You should be able to do that in your head. I have a +2 plus some number -14 has to equal 0. Okay? So this gets a little tricky because this total charge has to be plus 12, right? Okay, because that's what will give me 14. So the total charge has to be plus 12, but I have 4 of them. So I'm going to divide that by 4, which means each one of these is plus 3. And we will work on that. You now have enough information to do the 2 worksheets. So your first assignment is to complete the next 2 worksheets then. That is your assignment. So you should go to do worksheets.